Hello everyone. Today let's go over a medium question that I just solved by myself. After a lot of struggling, as you can see, I finally managed to do it. So again, this one's a challenge. So let's go over it. So the question itself is pretty simple. Return a Boolean based on an array of characters having a 1, 3, 2 pattern that's a subsequence. So basically start here, end here, anything that is smaller than the current. And this is also in between the two values, means that there's true. Okay, for example, this is 2, then it's between 1 and 3. Or if it has to be between 2 and 3, which there's not, then it would be true. So let's go through some more examples. Here there is a 1, 3, 2 pattern because, first of all, 1 and 4, right? 2 is between 1 and 4, right? And so here, 0 is between -1 and 3, right? So think of this as the current, and then this is the left side, and then we want to find an element on the right side that's between any number in the left and the right side. And that gets challenging because you want to avoid time limit exceeded. But let's first break this down and try to create two sorted lists for the left and right side. Let's call it a sorted list so we can run a binary search. Sorted list nums, and then iterate over nums from left to right. Okay, so now let's try to just get the current and then the left side and the right side. So let's say lefts.add or rights.remove nums of I, lefts.add nums of I, and then let's call this current. So we basically just want to get 1, 2, and then 3 and 4. 1, 2, 3, and then 4. All right, so that's just one example. So this is the current one. It's only the ones in between, not the first or the last. So if I is bigger than or equal to 0 and I is less than length of nums minus 1, then let's print lefts, current, and rights. Cool. So we got the picture, and time complexity is really important here. So let's make some optimizations. Call this n instead of length of nums. Okay, that might or might not help, but let's try this. And now, since we have this, we can start looking for an element that's between any two elements in this list. So if you want to make the biggest range between these two lists, you take the smallest element of the left side and the current element, right? So let's call left is going to be left 0 because this is already in sorted order. Both sides are in sorted order. And then let's call, well, the current is just the current. So now the job is to find any element in the right side, and the right's already sorted because of the sorted list, so we can run a binary search on it. Or the naive way I was doing before is just to go through rights and say if left is less than this current value, right? For example, not a good example, but example, well, this has to also be bigger than this one. So 2 is between 1 and 3, so return true. Or yeah, 2 is between 1 and 4, so return true as well. So if left is less than right, because this is less than the current element we're iterating over, and then it's also less than current, then we can return true, right? And at the end, if it's not true, then we can return false. Okay. Unexpected indent. Lefts.add. Oh, okay. Lefts.add nums of I. Let's clear this. I don't know why this is doing this. Oh, okay, there we go. So this technically works, but again, it's just way too slow. Let's get rid of the print statements. And this is what I had before. So, okay, you're not quite there. You're almost there. But this is O of n, and they don't like that. So again, we want to find, let's make this clearer. Let's say find an element in the right list that is between the smallest in the left list and current. So just to make this clear for the audience, let's do this. So for example, 1 is in between, 2 is in between 3, so this is valid, so the whole thing is valid because there is a 1, 3, 2 pattern in the input of a subsequence. So instead of doing this, how about we can just run a binary search? Okay, so let's call this low and high, and we're going to use the indices instead of the values because we have to find a value inside of this list. So let's call this 0, length of, what is it, rights -1, because we're binary searching. Okay, left.add nums of I, we're binary searching and right, and then we're just going to try to find an element and ask. So the current element or now is going to be what? Well, the midpoint, we have to cut the array into a half first with binary search. Low plus high divided by 2, so getting the middle index. And then now let's call this the value, which is just rights mid. So we're binary searching and rights. And then if, again, L, which is 1, is less than the current value, which is val, is less than current, which is 4, then we can return true, right? Otherwise, this guy is too big or too small. So if the value is bigger than or equal to current, because it has to be less than, both have to be less than the current. So if value is bigger than or equal to current, then we gotta cut the array in a half. So we gotta throw away the right half by moving the high pointer down. Otherwise, we have to move the low pointer up. And then eventually, if we do find a result, hopefully we will. And let's run this. And let's see. There you go. It's not the most efficient, but I did struggle a lot and came up with this myself. So really proud of this. Again, instead of doing the loop, just do a binary search and that will probably solve it. So, yep, that's it for this video. Hopefully this is helpful. It's a pretty tricky problem, and you don't have to use a monotonic stack like I showed you to do this. If you understand how sorted lists and binary search works, you can do it as well. So thank you for watching and stay tuned for more.